Okay, in the last lecture, we have studied the series expansion, and we have seen the Maclaurin series expansion, as well as we have seen the Taylor series expansion. Now, we'll try to move for more than one variable case. Okay, so we are familiar with the derivatives in the one variable case. So, for example, f is a function of x, and then we know what are the derivatives, or we treat y as a function of x, and then we know how to find out the derivatives. Okay, so what happens if we have more than one dimension? Okay, so this x is going to be one dimensional case. Okay, y is just a function of x, that's it. But now suppose y and x are independent. Okay, so there is no relation between x and y, and x is independent, y is also independent, and there may be some more variables which may be independent. So x is going to be independent, y is going to be independent, and again, suppose z is going to be independent. How we are able to find the derivative in these cases? Okay, so here we try to find the derivative. I hope you are able to see this journal.
Yes, sir.
Yes, sir.
Okay. Okay, so what if we have a function, okay, which is of more than one variable? So here we'll first try to understand two variable case, and that can be extended. Okay, so what you'll be having, like f is equal to the function of x and y, and x, y be the independent variables. So here, the possibility that the function y is a function of x is not there. Y is independent, x is independent, and both these are changing the function f. So there is no relation between x and y, but f is relating to x, f is related to y, f is related to x. Okay. So here, this x and y are going to be the independent variables. And now we want to find out the derivative. So you can see f has two parts, x and y. X and y are not related. Okay. So if it happens that y is the function of x, then here this f becomes x, f of x, and then again function of x. Okay, g of x. So ultimately it becomes only the function of x. But that is not the case here. Y and x are not related. Okay, and that's why this is not going to happen. Okay, so what we have here, f is the function of x and y. And moreover, x and y are independent. So if I consider the derivative with respect to x, or the derivative with respect to y. Okay, so here, if I am considering the derivative with respect to x, then I am able to find the derivative of a part only. Okay, because f x is one part of f and y is the other part of f. So here, if I am finding the derivative with respect to x, then I am finding the derivative of a part. If I am finding the derivative with respect to y, then I am finding a derivative of a part. And that's why these are called as partial derivatives. These are called as partial derivatives. So here we are considering a part only. We are not considering the entire function. Okay, and if this is the case that f is a f of x, the function of x, then this is a total function. So that's why these are called as total derivative. Okay, so we denote it by d by dx. And here we are considering the partial derivatives. So that's why we have a different notation. Then we know the first principle as we calculate f dash at x is equal to what we know, limit h tends to 0, f of x plus h minus f of x upon h. Okay, this is the first principle to find the derivative. Okay, so here we will be using the first principle, but it is now in more than one dimension. Okay, it is now in the case of more than one variable. So the next important thing that we need to understand is whenever we are using or we are finding the derivative with respect to one variable, the remaining all variables are treated as a constant. Okay, so whenever we are finding the derivative with respect to one variable, the remaining variables are treated as constants. Okay, so that means when I am finding the derivative with respect to x, obviously y is treated as a constant, and when I am finding the derivative with respect to y, obviously x is going to be constant. Okay, so when we say something is going to be constant, then while taking the derivative, we have to take care of that. Okay, so then once we know the f is going to be the function of x and y are the independent variables, then the partial derivative of f with respect to x is denoted by double f by double x and is defined as, yeah, so what we have, double f by double x is also denoted as fx is equal to limit h tends to 0 f of x plus h minus f of x on h. So you can see we are considering the difference or the variation in x only. Okay, we are considering the change in x only. Here y remains as it is. Okay, so here y remains as it is. That means we treat y as a constant. We do not consider the change in y. Okay, we consider the change in x only. Okay, so we have to be careful. F of x and fx. Okay, so these two things are not equal. So this notation says that f is a function of x, and this notation says that whatever the function f we have, whatever the variables we have, this is the partial derivative of f with respect to x. Okay, that's why we have to be careful. Okay, yes, Jayesh, and
So, in this f of x notation, is x in the subscript?
yes, x is a subscript, right?
Okay.
Okay, so this way we are able to define the first order partial derivative of f with respect to x. Okay, now we can define also the partial derivative of f with respect to y is denoted by double f by double y and is defined as, okay, so we can have here double f by double y is equal to, you can write fy, and this is limit k tends to 0. X is treated as a constant, so there is no change in x, but now there is change in y. So minus f of xy, and this divided by k. Okay, so here we are considering the change in y, and you can see x is remaining as it is. So it is going to be the constant. It is treated as a constant. Okay, so in first derivative, when we are finding the derivative with respect to x, we are treating y as a constant. So there is no change in y when we consider the derivative with respect to x. And now, when we consider the derivative with respect to y, then we are treating x as a constant. There is no change in x. Okay, so are you getting this one? Is there any doubt now?
No, sir.
Okay, that's good.
So,
Yes.
as normal differentiation represents the slope of the curve, what does partial differentiation represent in terms of graphical sense?
Yes. So it is now it is a surface here. Okay. So when we are considering x and y, it is going to be the surface. Okay. So this we can say tangential surface. Okay. This we can say the tangential surface. Or if I consider only the direction, then it is the tangent to that curve or to that surface in particular direction. Got it?
Yes, sir.
Okay, that's good. Okay, so this may be if I consider only x and y, this is going to be a surface. If I consider x, y, z, then this is going to be a volume. Okay, so like that we can have. Okay, now these are the first order partial derivatives. Similarly, we can define the second order partial derivatives. Okay, suppose we have these two derivatives, and now I differentiate this both of the derivatives with respect to x again. Okay, I differentiate this both of the derivatives with respect to x again. So if we differentiate this both the derivatives with respect to x again, then we have, okay, so what we can have is double square f by double x square. This is what we'll be having, double by double x of double f by double x. So the first term I have double f by double x, and I'm differentiating this again with respect to x. Okay, so we are able to get double square f by double x square, and this we can write as f x x. Now, if I consider double square f by double x double y. Okay, so this is double by double x of double f by double y. So it is going to be f of f x y. So it is going to be f x y. Now, as we have differentiated this both the terms with respect to x, we can differentiate this term with respect to y also. Yes, do you have any doubt or any query?
Sir, can we write that deba 2f upon deba x deba y as deba of deba y into deba f upon deba x?
Just wait. You want to say that double square f double x double y as double f by double x into double f by double y.
Sir,
Is that what you want to say?
no, sir. I am asking that deba upon deba y of deba f. Like
Double
deba.
f by double y.
No, sir. I am saying that deba upon deba y.
Double upon double y.
Of deba f upon deba x.
Double x.
Can we write it like that?
Okay, you need to have some patience because I have differentiated these two derivatives with respect to x. Okay, next I'm going to differentiate them with respect to y. Then we need to check what is happening.
Sir,
Okay.
why you wrote the subscript as f of xy? First, you should
This
write
one,
f of
x,
yx.
y.
Na?
This order, in this order.
Yes.
Okay, that's good. Okay, because we take derivatives in this order. Okay, so What it means that we have taken the derivative of this f with respect to x first, and then we have taken the derivative of this derivative of y with respect to x later. Okay, so first we have taken the derivative of this with respect to y, then we have taken the derivative of that first derivative with respect to x, and that's what I said. If I differentiate this above two first order derivative with respect to x, then we will be getting this one. Okay, and now we want to differentiate this two derivatives, whatever we have got earlier, this fx and fy with respect to y. Okay, so let us differentiate this derivative of x with respect to y, and this derivative of f with respect to y again. Okay, so if I differentiate this both the derivatives with respect to y, then what is going to happen, or what we will be getting? Okay, so here I can differentiate this Daba square. Okay, so what we are going to differentiate? Daba x, Daba f by Daba x. This is Daba x. With respect to y, we are differentiating, and Daba f by Daba y, we are differentiating with respect to y. Okay, so this we can write as Daba square f by Daba y Daba x. So that is going to be fyx. And this Daba by Daba y of Daba f by Daba y, we can write this as Daba square f by Daba y square, or this we can write as fyy. Okay, so this way we are able to get the second order partial derivatives. Okay, so this way we are able to get the second order partial derivatives. Okay, yes, Jason.
So can we denote the fyy as fy square?
No, that's not the notation. No, fy square we cannot write it. That's not the notation.
Sir,
Yes.
and deba 2f upon deba x deba y, if it is written, means we have to write deba x first if you want to differentiate with respect to x, right?
Yeah. See, that's why I said you need to understand the notation, okay, and you need to understand the order. Okay, so here we have already differentiated this f with respect to y, and then for this derivative we are differentiating with respect to x. Okay, here we have already differentiated f with respect to x, and now we are differentiating with respect to y, and so we'll get this notation in this particular order only. Okay.
Yes, sir.
Okay, Jason, you got your query clear?
Yes, sir.
Okay, so you got the idea of second order partial derivatives.
Yes, sir.
Okay, so once you have the idea of this first order partial derivative and the second order partial derivative, let us try to understand this with the help of an example. Okay, so let's try to have the example. So find Daba f by Daba x, Daba f by Daba y, Daba square f by Daba xx, Daba x Daba x square, Daba square f by Daba x Daba y, Daba square f by Daba y square, or f is equal to e raised to x into cos of dy. Okay, so this is going to be a function, and then we have to find, okay, what is the first order derivative of this function and what are the second order derivative of this function. Okay, so one by one we'll try to find. Okay, so let us try to have the first order derivatives. Okay, so because the solution, let f is equal to e raised to x into cos of b. Okay, b the function of x and y. Okay, this is going to be the function of x and y. Now here we know that x and y are going to be independent. Okay, so these are going to be independent. Now what we'll do is we want to find out this derivative. So we must mention that differentiating f with respect to x partially. Okay, differentiating f with respect to x partially, we get. So what we are able to get is w f by w x. Okay, so here this is w by w x of e raised to x into cos of dy. So what we have discussed that when we are finding the derivative with respect to x, y is treated as a constant. So this term contains y, that means cos of by remains constant and we'll be having w by w x of e raised to x. We know what is the derivative of an exponential function. So this is cos of by remains as it is, and this is a into e raised to x. So what we got here, okay, we got that w f by w x is equal to, so it is a e raised to x cos of by, let it equation 1. Okay, that's what the first term that we wanted to find. And then we got this first order derivative, partial derivative of f with respect to x. Now we want the first order partial derivative with respect to y. Okay, so how we are able to do it? Then we can write again differentiating f with respect to y partially, we get. What we are able to get is w f by w y is equal to w by w y e raised to x cos of by. Now here, when we are differentiating with respect to one variable, the others are treated as a constant. So we are differentiating with respect to y. And hence, what will happen to the term e raised to x?
Constant.
Yes, it is going to be constant. So we can have e raised to x out w by w y of cos of by. Okay, and the formula for derivative is going to be same. Okay, so what we get here? So this is e raised to x into, what is the derivative of cosine?
Minus sign.
So this is going to be minus sine of by, and again the derivative of by is going to be b. We are finding the derivative with respect to y. Okay, so we can write that we get w f by w y is equal to. So what is w f by w y? We have minus b times e raised to ax, and this is sine of by. Let this equation 2. Okay, so in equation 1 we got the derivative of f with respect to x partially, and then in equation 2 we got the derivative of f with respect to y partially. Now after getting this partial derivatives, let us see what we want. Okay, so is there any doubt this two partial derivatives that we have calculated?
No,
No,
sir.
sir.
No, sir.
Okay, all of you got these two partial derivatives?
Yes, sir.
Yes, sir.
Yes. Okay, that's good. Okay, so now let us try to calculate the second order partial derivatives. Okay, so we have equation 1, the partial derivative of f with respect to x. Then we have equation 2, the partial derivative of f with respect to y. Now you can see what we want. We want the derivative of this derivative with respect to x again we will have to differentiate it with respect to x. Then the derivative of first order derivative of y, we have to again differentiate it with respect to x. And again, the first order derivative of y, we have to differentiate with respect to y. Okay, so this way we have to find these three second order derivatives. Okay, so let us find one by one. Okay. Now we have equation 1. Again, we have to differentiate equation 1 with respect to x partially. Okay, so let us try to differentiate this equation 1 with respect to x partially. So we write here differentiating double f by double x. Okay, with respect to x partially. We get. Okay, so what we are able to get is, see, this will be double square f by double x square, which is actually double by double x of double f by double x, and this is double by double x. What we have here, a e raised to ax also by. That's what we'll be having again. So a cos of by is a constant. Now again we have double by double x of e raised to ax. So what we are able to get this is equal to a remains as it is, cos of by is treated as a constant, and you have a into e raised to ax. So we can write a square e raised to x cos of by. So that's what we'll be having. This is double square f by double x square is equal to a square e raised to ax into also equation 3. Now, if we see the next, so we have to differentiate equation 2 with respect to x. So let us differentiate equation 2 with respect to x. Okay, so we write here, hence, differentiating equation 2 with respect to x partially. We get. So what will be having double by double x of double f by double y, and that we write as double square f by double x double y. So this is double by double x of minus e raised to ax, and this is what we'll be having sine of by. Okay, so that's what we have in equation 2. Okay, so you can see here, this is what we have in equation 2. Now we are differentiating with respect to x. So minus b sine of by is treated as a constant. So double by double x of e raised to ax. Then that we have seen, what we do is going to be minus b sine of by into a e raised to ax. So we can write this as minus ab e raised to ax into sine of by. So we got here double square f by double x double y is equal to minus ab e raised to ax sine of by. So that's going to be the next equation. So we can, yes,
Excuse me, sir.
yes,
So, sir, in final equation, you wrote d by square f upon d by x and d by y.
Hmm.
So it is necessary to write it in order. Means first
yes,
we
yes.
yeah.
No,
So
it
first
is necessary to write in order. Okay, why? You can see because we have defined the second order derivative. That's why I have written these two derivatives, not the same one. Okay.
But sir, deba square f by deba x and deba y is equals to deba square f divided by deba y and deba x. No?
That is
same.
true.
That's why I'm saying.
So yeah, that may be true for some functions, but not for all functions. Okay, so here the order is going to be different. We have to consider the order. Okay, and that's why we have these two different notations, not the same. Okay, so when we consider
Means, sir,
When we go for
First
more
we-
variables, you will find it. Okay, just wait. When we'll go for more variables, you'll find it in a different way. Okay, this is just the two variable case that we have defined.
Okay, sir.
Okay. Okay, so we got the first order derivative with respect to x. Okay, we got the first order derivative with respect to y. Then we differentiated this first order derivative of x with respect to x again. Okay, then we differentiated the derivative of f with respect to x again. So derivative of f with respect to x, and then we differentiate y, then we differentiated with respect to x again. Now, what is the next derivative that we want? We want double square f by double y square. That means we want the derivative of double f by double y with respect to y again. Okay, so let us try to find the derivative of this double f by double y with respect to y. Okay, so let us differentiate. What we can say is differentiating equation 2 with respect to y partially. Okay, so we have what will be having is equal to double by double y of double f by double y, and this we write as double square f by double y square. So this is double by double y of minus b e raised to ax, and then we have sine of by. Okay, so when we are finding the derivative with respect to y, x is treated as a constant, and we know a and b are going to be constant. So this minus b e raised to ax, and we'll be having double by double y of sine of by. Okay, so we can have this is minus b e raised to ax. We'll be having the derivative of sine by is equal to cos by into b. Are you getting this term?
Yes, sir.
Yes, sir.
Okay, so can we write this as minus b square e raised to ax into cos of by? You're getting this now. So we have here double square f by double y square is equal to minus b e raised to ax cos of by. Okay, and that's what we can have the next equation, or that's what we wanted to find. So this is going to be
Sir, it's b square,
Sir,
no?
minus b square, na sir?
yes, it is going to be b square. Okay, so it is minus b square e raised to ax into cos of by. So you got this one.
Yes,
Have you
sir.
got this example?
Yes, sir.
Yes, sir.
Is there any doubt in this example?
No,
No,
sir.
sir.
No, sir.
See, finding the derivatives or all the rules for derivatives are going to be same. Okay, only thing that we need to understand is if it is a multivariable case, then whenever we are differentiating with respect to one variable, the others are treated as a constant. So other terms will be constant. Okay. So you can just go through this example once again. Okay, and let's just see if you have any doubt. So if you have any doubt, you can ask.
No, sir. No doubt.
Sir, in exam, can we write directly without showing these steps?
Yes.
In exam, can we write directly the derivative, the partial derivative, without writing the steps?
It is always better to write the steps. Okay, so that the reader will understand that you know it perfectly. because it is necessary to understand that how we calculated it. Okay, so that's why we have to show, we have to write that how we get it. Okay, and that's why the steps are important. Got it?
Yes, sir.
Okay. Okay, now let us try to have the another example. Okay, so we go for the next example.
Sir, how do
Yes.
you pronounce that differential operator? Is it DABA or what is that?
Daba. See, the total derivative. There are the notations D we have seen earlier. Okay, then this is Daba, and then this is another delta. Okay, so D is for one variable. D is for one variable case. Okay, Daba is for more than one variable. And this is small change or increment. Okay, so that's how these three notations are different. Okay, so when you have this D, if you have Y is the function of X. Okay, when you have this Daba, if you have U is the function of more than one variable, or F is the function of more than variable. And then this delta, we have used at, if you remember limit delta X tends to 0. Here we have used delta Y upon delta X, and this we write as d by dx, or we write as dy by dx. Is
Sir,
that
means
okay?
delta is little more than D, na? In size.
Oh, see, these are different notations. This is gamma, this is delta. Okay, these two are different symbols. Okay, these two are two different.
Sir,
These
is
are,
delta same as triangle?
pardon?
Is the delta symbol same as triangle we had learned earlier in 12?
Yes. Yes. The see, as we have the capital letters and small letters. Okay. So when you write in terms of triangle, that is capital one. Okay. When you write in terms of this is the small one. Okay. So as we have capital letter and small letter, so we have this capital letter and this small letter. Yeah, these are the Greek letters. Okay.
Okay, sir.
Yes. So that's why we have to be very careful for the notation in mathematics. Okay. That also we'll see. Okay. In our next model, we'll see that one. Okay. Now here, so is there any doubt in this example now?
No, sir.
No doubt. Okay. Okay, that's good. Okay, so we go for the another example. So we can have, if u is equal to e raised to xyz, okay, then find double cube u by double x, double y, double z. So we need to understand the question properly. Okay, so if u is, this is the function of x, y, and z. So here u is e raised to x, y, z. Then we have to find out this derivative. Okay, so we need to understand while finding this derivative, I have given you the idea how to find the derivative and what is the direction to be used. So first step, we have to find the derivative with respect to z. Second step, we have to find the derivative with respect to y. And third step, we have to find the derivative of this with respect to x. Okay, so this way we have to solve this problem in 3 steps. Okay, so these are the 3 steps. First step, we'll find the derivative with respect to z. Then second step, we'll find the derivative of that with respect to y. And then third step, we'll find the derivative of that with respect to x. Okay, so let us try to find what we are able to get. And the most important thing is that whenever we are finding the derivative with respect to one variable, the other variable are treated as a constant in case of partial derivatives. Okay, so that is most important thing that you need to understand. And here y is not a function of x, neither the z is a function of x. X, y, and z are independent variables. So there is no relation between these two. Okay. Now, let us see Anshul what we are able to get. Okay, so good try. Okay, and let us have the steps. That's why the steps are important. Okay, somebody asked me, can we write directly? So let us see what happens. Okay, so what we'll be having, let u is equal to e raised to x, y, z be the function of x, y, and z. Okay. Now we have to differentiate this with respect to z first. So what we do is we have to write differentiating u with respect to z partially. So always write you are differentiating partially, because if you don't write, then it is considered to be a total derivative. But total derivative is not possible in this case, as we have more than one variable. So whenever you have more than one variable, always write that you are differentiating partially. Okay, and hence what we'll be getting, we get w by w z. Okay, so always there should be a difference between 2 and z. That's why I write z always like this and 2 like this. Okay, so we are differentiating with respect to z. So when we are differentiating with respect to z, x and y are treated as a constant. So what you'll be having, so we can have, this is w by w z of e raised to x and y treated as a constant, and here we have, this is going to be z. So what will happen, this term remains as it is, so it will come down, e raised to x into y into z. So xy will come down, and then you will be having e raised to xyz. So are you getting this derivative?
Yes.
Yes, sir.
Okay, good. So what we got here, we got w by w z. Okay, w by w z is equal to x into y into e raised to xyz. Okay. Now, what is the next step? We have to find out the derivative of this with respect to y. So whatever the equation we have got here, we have to differentiate this equation with respect to y. Okay, so we write here differentiating above equation with respect to y partially. We get. So what will be getting? W square u by w y w z. So here we have to find the derivative with respect to y, and here we'll be having xy e raised to xyz. So now when we are finding the derivative with respect to y, x and z is treated as a constant. So this is x, which is a constant, so we can take it out, and you'll be having y into e raised to xz into y. Okay, because we are going to treat x and z as a constant as we are finding the derivative with respect to y. Okay, now here we have to use u into v rule. Okay, so what we know about u into v rule, if I consider the derivative of u into v, then what we know is u derivative of v plus v derivative of u. Okay, that's what we have. Now this is going to be u and this is going to be v. Okay, so let us try to find the derivative. This x remains as it is, so x is going to be constant. Okay, this x is going to be constant. Now think of this y. the derivative of y is going to be 1, and this e raised to xyz remains as it is. Okay, plus this y remains as it is, and the derivative of this term, so it is x into z e raised to xyz. Are you able to get this derivative?
Yes, sir.
Are you getting this derivative? Yes. Okay, so let us simplify. This x I'll multiply, so I'll be having x plus I'll be having x square yz, and this term is e raised to xyz. Are you getting this term? So here what I did is I have taken this e raised to xyz common, which is here, and multiplied by this x inside. So here I have xyz. So multiplied by x, it will become x square yz, and here 1, so multiply by x, so we'll be having x. So what we got here, this we got as double square u by double y double z. Now you can see finally the third step. What we have to do is we have to differentiate this all with respect to x. Okay, so whatever we have got here, that we have to differentiate with respect to x now. Okay, so let us differentiate. What we'll be having here, differentiating above equation with respect to x partially, we get. Okay, so what we are able to get here, this is double cube u by double x double y double z. This is equal to double by double x of x plus x square yz e raised to xyz. So again, here we have to use u into v root. Okay, so this term is going to be u, and this term is going to be v. Now, if we consider u remains as it is, x plus x square yz, this remains as it is. The derivative of this will be y into z e raised to xyz, because we are differentiating with respect to x, so y and z are going to be constant. Now plus, again, so e raised to xyz is going to be constant, and the derivative of this, what is the derivative of x?
1.
1. What is the derivative of this x square yz with respect to x?
2x yz.
Yes, it is going to be 2x, y, and z. Okay, so that's what we'll get. Now we can have this term common. So we have to multiply by this. So you'll be having x, y, z plus you'll be having x square, y square, z square. Plus, what is the term you'll be having here? 1 plus this is 2x, y, z. And this x, y, z is going to be common. Now simplify. So we got here, this is double cube u by double x double y double z. This is equal to, what is the term we'll be having? 1 plus 3x y z plus x square y square z square into e raised to x y z. And this is what the answer, or this is what the term that we want to calculate. So we got this term here. Okay, so now you can check your answer, whatever you have guessed earlier. Okay, now what we got here. Okay, and that's why the steps are important. Okay, so this is how we are able to get the answer if you solve the example step by step. Okay, definitely you will get the correct answer. So here, when we read the question, okay, we need to understand the question first, how we are going to solve the problem, what are the steps, and then we have to follow that step. Okay, so we always say that we have to first understand and then solve. Okay, so is there any doubt?
Yes, sir, I
Yes.
have.
Yes, please.
Sir, can you please show your screen?
Okay. Yes.
Thank you, sir. So can you please scroll down a little bit to our
Yes.
question? To our question. Okay, sir. Sir, I have doubt that we did the double cube u upon. So what is the double at double?
Above by
Double x, double y, and double z. So,
Huh.
sir, here the order is x, y, and z. So, and we did calculations from z, y, and x, right, sir?
yes.
Okay.
Got your query solved. Why we followed that? Why we made the step number 1, step number 2, or step number 3? So how we decided which step we have to take first is this one.
Okay, sir. Okay, fine.
Okay. This is I have defined in case
Yes,
of
sir.
2 variables. So we can have it in case of 3 variables. So that derivative we have calculated is one of the third order derivative. Okay, there will be 9 derivatives. So that will be one of the third derivative, one of the 9 derivatives, which is third order. Got it? So that's why I have marked what steps we have to follow and which direction we have to follow. Okay.
Yes, sir. Absolutely fine.
Okay. Good. Okay. So have you got this question? Is there any doubt in this question?
No, sir.
Okay. All of you got this?
Yes.
Yes, sir.
Okay. That's good. Okay. Now let us try the another question. Okay. So we go for the next question. If f is equal to 8x square y plus xy square, then find x double of y double x plus y double of y double y. And so this is what we want to find. Now, this is the first order derivatives would be the first order partial derivatives we have to find. What are the steps involved here? Okay, so here 2 steps are involved. First, finding the derivative and then multiplying it by x. So this will be your equation 1. Now, what we have to do next? So here we have to find the derivative with respect to y and then multiplied by y. So this will be your equation 2. And once you get equation 1 and equation 2, what you have to do is you have to add this to equation to get this right. Okay, so this way we need to first understand the question, what exactly we have to do. So all you got the idea what we exactly we have to do? Have you got the idea?
Yes,
Sir, it
sir.
is
Yes,
equals
sir.
to x
Yes, sir.
y square.
Same question.
Yes.
So the question is plus 2xy square. No?
Yeah, it is 8x square y plus 2xy square. That's true.
Yes, I think it was there.
That's why I said when I'll write z, I'll put one line. If I do not write that z, that means it's going to be 2. Okay, so we have to take care for our notations, whatever we are going to use. Okay, so this is going to be 2. Okay, so is the question clear to you now? So what you'll be having here, let f is equal to 8x square y plus 2xy square. Okay, so that's what we have. Okay, let us see what we get. Okay, so B, the function of x and y. Okay, now whatever the steps we have noted, so we have to follow them one by one. Okay, so what we do first, we differentiate. Differentiating f with respect to x partially. Okay. Now, if we differentiate this partially with respect to x, what we'll get is we get double f by double x. Okay. So if I differentiate this, what I'll get is 16x y. Y is treated as a constant when we are differentiating with respect to x. Plus, we'll be having 2. The derivative of x is going to be 1, and this y square remains as it is. So this is the first step that we have completed. Now, second step, multiply this by x. Okay. So multiplying above equation by x, we get. What we are able to get is x double f by double x is equal to x. So if I multiply 16xy plus 2y square, so it is going to be 16x square y plus 2xy square. Okay, so that's what we are able to get. Now, this is equation 1. Okay, so we got x double f by double x is equal to 16x square y plus 2xy square. That is equation 1. Now, we have to go for next. So for this, what we have to do is we have to differentiate f with respect to y and then multiply it by y. Okay, so let us differentiate. Hence, differentiating f with respect to y, we get so double f by double y. So this is double by double y of 8x square y plus 2xy square. So this is 8x square is going to be constant, and then the derivative of y is going to be 1 plus 2x square is going to be constant. 2x is going to be constant, and the derivative of this y square is 2y. So we can say double f by double y is equal to. So what we got here? This is 8x square plus 4xy. Now, what we have to do the next? We have to multiply this by y. So let us multiply this equation by y. Okay, so we write here multiplying above equation by y. We get. So what will be having y W of by W is equal to y. This is 8x square plus 4xy. So we can get 8x square y plus 4xy square. So we got y W of by Y is equal to 8x square y plus 4x y square. So let this equation. So we got both the parts that we needed to find our claim. Okay, so we got this part, we got this part. Now let us add this equation 1 and 2. Okay, so what we can have is hence adding equation 1 and equation 2. We have, so what will be having x W of by W x plus y W of by W y, and that is equal to. So we get here, see, the first term that we have here, you can see it is 16x square y plus 2xy square. So this is 16x square y plus 2xy square, and plus this is 8x square y plus 4xy square. So we can have x W of by W x plus y W of by W y is equal to. What we get here, so it is 24 x square y plus 6 x y square. That's what the answer we have to find. Okay, so this is what we wanted to find. We got W x W by W x plus y W by W y, and that's going to be 24 x square y plus 6 x y square. How many of you were able to get this answer? Okay, so there were few guesses. Okay. Okay. So that's good. You got, if you got this answer, that's good. Okay. If you have not got this answer, then you can find where you have committed a mistake, and then you were not able to calculate it properly. Is there any doubt in this example? Please lower your hand now. Is there any doubt in this example?
No, sir.
Okay, all of you got this answer?
Yes, sir.
Yes, sir.
Yes.
Okay. If you have any doubt, you can ask. Okay. So is this
Sir,
example
if we don't write the whole explanation, will you cut the marks?
what?
If we don't write this whole explanation, full page, so will you cut the marks in examination?
See, we should write in such a way that the reader should able to understand. Okay, that should be our focus. Okay, as like for me, you are the reader. Okay, so when later on you will read this, you will understand what we have done. Okay, and so it should the way you should write is for others. Okay, so you will be writing for examiner. So you will not be there to present yourself, and that's why your writing will present yourself. So if you write in a proper way, the examiner will able to understand easily. Okay, Otherwise, just a calculation is okay. But what we have done in that calculation, okay, what that calculation means. If you write, this is better always. Okay, so it is not about the marks. Okay, it is always about the understanding. Okay, so that's why I asked you whether you got it or not, or if you have any doubt or anything. But in examination, you will not able to ask this question, no, that sir, whether you have understood it or not, or you have doubt. So if the examiner has doubt, he will cut down your marks. If examiner will understand properly, then he will credit you full marks. Okay?
Okay, sir.
Yes, sir.
Yes.
Sir,
Excuse
can
me,
we
sir.
get 5 minute break?
Just wait. Somebody is asking. Yes, please.
Sir, can we write the now this answer in simplified form by taking common 6xy?
Yes, definitely we can write. Yeah, definitely we can write.
Okay, sir. Thank you.
So simplification is always possible. If you can simplify, go on simplifying. Okay. If you cannot simplify, stop there. Okay. As this question was not to prove that something. Okay. I would have written this question to prove that like that also. Okay. But when we write or when we see the question, prove that, show that, we always try to drag the answer. Okay, so anyhow, we'll try to prove that whatever the given statement is. Okay, so but don't try to drag the answer, don't try to prove anything. You just calculate properly with the proper steps and proper formula. Okay, definitely you will arrive at the correct place. Okay, or you will arrive at the correct claim. Okay, so that's why this question is actually prove that. Okay, but I didn't write the right hand side. So I want it to be calculated properly. Okay, so you need to split the claim into smaller claims. Okay, and then collect all those, and then collectively you can say yes, this is the conclusion. Okay, and yes, always it is possible if you can write in a simplified form, you can go for it. Okay.
Thank you, sir.
Yeah, welcome. Okay, so you got this question clearly.
Yes, sir.
Okay, so let us try to go for next. Okay,
Can we take 5 minutes break?
okay. So if you don't have any doubt in the previous example, we can go for the next. Okay, so let's go for the next one, right? Okay, now we need to understand what if we know more information about this function. Okay, so suppose I know some property of the function, or I know something more about this function. So right now we have not considered anything about the function. We just consider the definition of the function, and then we have considered the terms in the function, and then we have calculated. Okay, so let us try to understand. If we know, as in the previous case, okay, we had a function and then we prove that what happens to x double f by double x, and what happens to the term y plus y double f by double y. Okay, so let us try to go for the next example. So we have if u is equal to log of tan x plus tan y plus tan z. Then find sine of 2x w by x plus sine of 2y w by y plus sine of 2z w by z. This is what we want to find. Okay. We know the derivative of logarithmic function. What is the derivative of log x?
1 by x.
1 by x.
1 by x.
Okay, so if that x is replaced by the function, okay, suppose instead of x we have f of x. So what will be the derivative of d by dx of log of f of x? What will be this derivative?
1 by f of x.
By f of x dash x.
By
Into
f of x into
f
f
dash
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 of
x.
x. Okay, or d by dx of f of x, right? Okay, so here we need to understand this rule and we have to use this formula to find this given claim. Okay, so again we need to understand how we are able to find a given claim. So we have these three terms. Okay, so we have the derivative with respect to x, we have the derivative with respect to y, we have the derivative with respect to z. Moreover, these are partial derivatives. Okay, so here we have to first find the derivative with respect to x, multiply it by sine 2x. Okay, and then this will be your equation 1. Okay, so here again find the derivative with respect to y, multiply it with the by sine 2y. So this will be your equation 2. And again, what do you have here? So find the derivative with respect to z, multiply with sine 2y, and then this will be your equation 3. Then add this equation 1, 2, and 3, we'll get our claim. Okay, so let us try. We have let u is equal to log of tan x plus tan y plus tan z be the function of x, y, and z. Okay, so what we have to do is, as we know here, we have to find out the first order derivatives. So first, let us find out with respect to x. So we can say differentiating u with respect to x partially, we get. So what we are able to get is u by x. This is equal to. So here, this entire bracket is going to be function. So what we get here, 1 upon tan x plus tan y plus tan z into the derivative of this term. So what is the derivative of tan x?
sec square x.
Sec square x.
Yes, it is going to be sec square x. What will be the derivative of tan y?
0.
It is going to be constant because we are differentiating with respect to x. So it's going to be constant. That's why the derivative of tan y will be 0 and tan z will be 0 with respect to x. We are finding with respect to x. So here we got this w by x as sec square x on tan x plus tan y plus tan z. Now, what we have to do the next, we have to multiply with respect to sine 2x. We have to multiply this this equation with by or by sine 2x. So let us multiply this by sine 2x. Okay. So we can write here multiplying above equation by sine of 2x. We get, so what we are able to get here, sine 2x into w by x is equal to sine 2x into sec square x upon tan x plus tan y plus tan z. So what we know, sine of 2 theta, what is that?
2 sine theta cos theta.
Sine theta cos theta, right? And what we know about sec theta?
1 upon cos theta.
1 upon cos theta. Now we have to multiply these two. Okay, so you'll be having sec square is equal to 1 upon cos square. So what will be having sine 2 theta into sec square theta. So this is 2 sine theta cos theta upon cos square theta. So can we write this as 2 sine theta upon cos theta, and that is nothing but 2 tan theta?
Yes, sir.
Yes, sir.
Okay, so here this is going to be 2 sine x into cos x into sec square x upon, this is going to be tan x plus tan y plus tan z, and this is 2 tan x upon tan x plus tan y plus tan z. Are you getting this?
Yes,
Yes,
sir.
Okay. So good. Now this will be your equation 1. Okay. So what we get here, we get sine of 2x w by x. This is 2 tan x tan x plus tan y plus tan z. So let it equation. Now we can see the next. So same thing we have to repeat with y. Okay. But do not write similarly. Okay. It was similarly should not be written. We have to find and we have to show. Okay. So we differentiating u with respect to y partial. We get, okay. So w by y is equal to, now we'll be having sec square y. This is tan x plus tan y plus tan z. Okay. Now what we have to do next? We have to multiply this by sine 2y. Okay. So multiplying above equation by sine 2y we get. So what you'll be having, sine 2y is be careful while writing sine 2y w by y is equal to. So we'll be having sine 2y into sec square y on tan x plus tan y plus tan z. So this is 2 tan y. Okay. And here we have tan x plus tan y plus tan z. So we got here sine 2y w by y is equal to 2 tan y upon tan x plus tan y plus tan z. So this is equation 2. Now see what we want. We want to do with the z variable now. So let us find the expression for the z variable. So what we do, again we have to start with differentiating q with respect to z partially. We get, okay, so w by w z is equal to sec square z upon tan x plus tan y plus tan z. Then next step, multiplying above equation by sine of 2z. We get, so what we have here, sine of 2z w by w z is equal. So this is sine of 2z into sec square z upon tan x plus tan y plus tan z, and that is 2 tan z upon, this is tan x plus tan y plus tan z. So you can write this as equation 3. So we got equation 3, sine of 2z w by w z is equal to 2 tan z upon, this is going to be tan x plus tan y plus tan z. Okay. So this is equation 3. And hence, what we have to do next? We want to prove the claim. So adding equation 1, equation 2, and equation 3, we get. So what we wanted to prove, that sine of 2x w by wx plus sine of 2y w by wy plus sine of 2z w by wz, and this is equal to, so you got 2 tan x upon tan x plus tan y plus tan z plus 2 tan y upon tan x plus tan y plus tan z plus 2 tan z upon tan x plus tan y plus tan z. So you can see we can have 2 tan x plus 2 tan y plus 2 tan z upon tan x plus tan y plus tan z. So we can write this as, okay, so what we are able to write this, so that
Sir, it
sine,
is 2 tan z, no?
yes, it is 2 tan z. Okay, so sine 2x w by wx plus sine 2y w by wy plus sine 2z w by wz is equal to 2 into tan x plus tan y plus tan z. And here it is tan x plus tan y plus tan z. So can we cancel these brackets?
Yes, sir.
Yes, sir.
Yes, sir.
So we get a very nice answer. So sine 2x w by w x plus sine 2y w by w y plus sine 2z q by w z is equal to 2. So this is what that we wanted to find. Okay. So we wanted to have this clean, and you can see if we try step by step, we write it properly, then definitely we are going to get the correct answer. So here we followed these steps. Okay, so we first try to understand what the question is. Okay, and once we got this question, once we understood this question, we just try to calculate the steps, the terms, and then we added equation 1, equation 2, equation 3, and then we got our claim. Okay, so this way, once you read the question, okay, try to understand it. Once you understand, break it into smaller parts, and then solve that smaller parts, and then recollect all the things. So definitely you are able to get the correct answer. Okay. Yes. So most of you got it. Good. Okay. So is there any doubt in this example?
No,
Okay. No
No,
doubt.
sir.
Okay, that's great. Okay, so all of you got this example.
Yes, sir.
yes, sir.
Yeah, sir.
Okay, that's good. That's good. So will you able to solve the problem based on partial derivatives now?
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
Yes, sir. Yes, sir.
Okay,
yes, sir.
so that's good that you got the idea of partial derivatives now. Okay, great. Okay, if you have any doubt, you can ask.
No, sir, no doubts.
That's good.
No doubt, sir.
Okay, that's good.
No doubt, sir.
Good.